Then we have what is called password attacks, which is aimed to grab, the attacker wants to grab his hands on the user's passwords for various platforms. Either it's going to be an operating system like Windows, Mac, or Linux. Either it's going to be a social media account password or an email account password. It all depends. In the end, it's still, the attacker still has the scope to grab his hands on the user's passwords. And there are various methods to identify what is the user's password. One of it is going to be guessing, which exploits weak passwords. Like in different regions of the globe, people use pretty much common approaches to creating passwords. Like in country X, people may use their birth date and their pet name as the password. Or in other countries, people may use specific naming conventions for the passwords. Like for example, a lot of IT engineers, when they build new systems, they put in their temporary passwords that they forget about it in the end, and those temporary passwords are going to be a commonly used password across all systems, which is also commonly known in that matter. It can also be done via dictionary attacks. So it's a lot of publicly available dictionaries with commonly used passwords, and you can make use of those dictionaries in there to identify if your target's, your victim's password is making use of one of the commonly used passwords across the internet. Or finally, if none of the above methods work, it's going to be a brute force attack, which is going to be used as a gateway of last resource in the end. It is the most time-consuming type of attack, but it has the most chances of succeeding. So a brute force attack is going to be a system which was going to happen is going to constantly send authentication requests to the victim, and it's going to choose random usernames and passwords to see if any of those random usernames and passwords are going to be succeeding. So that's called the brute force attacks, where in case I cannot guess the password, in case I cannot consider that the user uses a commonly used password, the dictionary attack, then I'm going to go ahead and try and use pretty much all of the possible combinations of the password in there, which takes a lot more time, but at some point it is going to be successful. How do you protect against those kind of attacks? So first of all, do not store the passwords in clear text at rest or in transit. So this makes sure that the password cannot be stolen by the attacker. So for the attacker to grab their hands on your password, they may have to steal it or guess it, or maybe they don't have to steal it. Like for this use case, make sure that in the user databases with usernames and passwords, or in network devices configuration files, you don't store passwords in clear text, because if the attacker grabs his hands on the database or on the network configuration file, then it's going to see the clear text password and make use of it. And this is a very commonly used type of attack, because unfortunately a lot of companies, they don't put in the proper security measures to protect them, to store the passwords not in clear text or as a specific file that contains passwords. It has to also be protected while in transit. So it's, for example, instead of guessing, let's say you want to grab your hands on the passwords of a lot of Facebook user accounts. Instead of trying to launch a brute force attack or dictionary attack against each account, it's way easier to try and get access within Facebook's inside network, get in the database, and if the passwords are being stored in clear text or not in clear text by using a weak algorithm, then once you copy the database of users and passwords, you can easily break it and find what is the clear text password. That's a common approach actually. Likewise, force users to create strong passwords through policies. So what that means, what most commonly happens is that users will be forced by their computers or by their email accounts to create strong passwords, and in the end what happens, the users are going to end up writing down those passwords on piece of papers. So that means you have to make sure that you constantly monitor for that not to happen. You can optionally help the users not to be forced to type in their complex passwords on papers by implementing multi-factor authentication systems. Or for example, you implement for a user to get access to a system is going to require both a digital certificate and username and password. And then the username and password combination can be simple, not complex, so the user can retain it easily. But then it also requires the certificate, which can actually be stored in a safeguarded flash card or USB stick, which the user has to connect to its computer to be actually be readable and usable to authenticate. Another method would be to implement one-time password systems, which means that you still make use of complex passwords to authenticate to systems, but those complex passwords will be generated by tokens, so the user is going to visually see what the password is generated by the token, and then type that in the authentication window of the system requiring authentication. Now, those complex passwords generated by OTP systems can be time-based, which means they are valid within specific time intervals, or they can be event-based, which means those passwords are valid only within specific windows of possible passwords.